Okay, I'm just going to do a quick little primer for you to get you thinking about motion once again. This next unit that we're into is going to be all about projectile motion, and projectile motion is most simply summed up as motion in two dimensions. Everything that we've talked about so far has involved either objects moving horizontally or vertically, but we've never analyzed something that's moving in two dimensions. And so the assignment that you're going to be working on today involves free fall motion or objects moving in the y direction, and then we'll get into two-dimensional stuff first. So really this first assignment is mainly review. First of all, in terms of review, our motion equations are delta x equals v naught t plus 1/2 a t squared. V equals v naught plus a t, and v squared equals v naught squared plus 2a delta x. Well, when it comes to the motion equations, really the delta x part of it is just to show the movement in the horizontal direction. We can also write these equations as if we were dealing with the vertical, in which case we would say delta y equals v naught t plus 1/2 at squared. V equals v naught plus a t, and v squared equals v naught squared plus 2a delta y. To further show the differences between the dimensions, we could also give subscripts to other variables such as the initial velocities and final velocities. Talking about the velocities in the x direction. And we can do the same thing over here for y. We can also do the same thing for the acceleration. We could differentiate between acceleration in the x and the y direction. But we would not do that for time, because no matter what happens in terms of how many dimensions of motion, one dimension, two dimension, three dimensional, if we were going to do three-dimensional motion, the time aspect is going to be the same. Okay, but there's our equations. So just to kind of look at a problem here. Let's say we have a person. My smartboard's not lined up very good. And let's say they're 2 meters tall. And they're going to throw a ball up into the air, and then it's going to come back down and hit the ground. Okay. And let's say they throw that ball with an initial velocity of 2 meters per second. The motion here is completely in the y direction, up and down. We have no x component. So I'm just going to make a little data table here, y. And then my different variables, change in y, initial velocity in the y direction, final velocity in the y direction, acceleration in the y direction, and time. Okay. I want to make a data table like this so one, I can keep my data organized, the numbers that I know, things that I might have to solve for, but also when we start doing projectile motion and we have two dimensions of variables, having them organized into a data table is really nice. So what do I know about my problem here? Well, I know I throw the ball with an initial velocity of 2 meters per second, but what's going to be important here is what is positive, what is negative. So if I do my x, y plane, I'm going to call up positive and down negative. So my initial velocity in the y direction is going to be a positive 2 meters per second. I don't really know what the final velocity is going to be, because when I throw it up and it comes back down, not really sure about that. Acceleration, though. The only acceleration that it's experiencing is acceleration by gravity, and that's 9.8 meters per second squared, but it's going to be negative. And then I also know the change in position. The ball starts 2 meters off the ground and goes up and then comes back down. So if we look at the before and after, it starts 2 meters off the ground, and at the end, it's going to be 2 meters lower than it was. And so the change in y is negative 2m. So I don't know either of these variables, but let's see if we can figure them out. So if I look at my equations up here, time shows up in 2 of them. I know my change in y, I know my initial velocity, I know my acceleration. I could solve that equation for t. I don't know my final velocity, so I can't really use the other ones. But if I look at the last equation here, final velocity squared equals initial velocity squared plus 2a delta y. I know all of those things except for the final velocity. And if I find the final velocity, hold on, I'm getting a phone call. So as I was saying, if we look at the last equation, we can find the final velocity of the object when it hits the ground. And then if we knew that, we could use the final velocity, initial velocity, and acceleration to find the time that it took for the ball to go up and come back down. So then let's do that. So v y, squared equals v naught y squared plus 2 ay delta y. So vy squared equals, let's see, 2 squared plus 2 times negative 9.8 times negative 2. And so what do we get for that side? So that side comes out to 43.2 vy squared. So then we have to do the square root to get the final velocity. And we get 6.57 meters per second. So that's going to be this right here. Now, with that though, it is going to be negative 6.57 meters per second because it's moving down at this point. That's how fast it'll be going when it hits the ground. As far as the time that it takes, we know that the final velocity now is negative 6.57 meters per second. The initial was 2 meters per second, and it's 9.8 meters per second squared times time. And so let's see here. Negative 6.57 minus 2 divided by negative 9.8. And the time is 0.87 seconds. Yeah. So this really doesn't take very long. This thing only going 2 meters per second when it initially gets tossed up doesn't go up very far before gravity slows it down and brings it back to the ground. If we wanted to find the maximum height that it reached, then we would want to find the final velocity. We would set the final velocity to 0 because when it reaches the high point, the velocity would be going from +2 down to 0, then it would become negative as it falls in the other direction. So then you can figure out exactly how high up it goes. But considering it's only going 2 meters per second and it accelerates downwards at 9.8, it goes very, very slowly. So really this is kind of like just hopping it in your hand and having it hit the ground. So anyways, I just wanted to review those equations with you and some problem solving. Of course, you need to pay attention to signs and stuff. But your assignment for tomorrow is posted to Edmodo. Solve those problems and we'll take a look at the answers to that on Monday.